third lecture, and we'll continue from where we stopped last week. Last week, we looked at you have more concepts that you'll be introduced to that you can build upon. So basically, you'll be applying what you learned today with also what you've learned in the previous week. Alright, so moving on. This is our outline. Okay, let me increase my volume a bit. Okay, so I think my volume is fine now. So conditional statements last week. So this week we'll look at data structures, and then if we have time we'll look at loops and then functions. Okay, but anywhere we stop we'll continue next week. So data structures that you may find handy for the different things that you may be interested in doing. So we have list is the first one we'll be looking at, and basically to declare a list in Python we use square brackets. Okay, you need to note that lists are mutable. That means that their values can change as the program runs. So you can declare a list with some values, you can clear the list, and then you can also add more values to the list as the program is running. Okay, so to add a new item to the list, you use the append method. So this is how you write it, append. Okay, so you use the append function or method to add new items to your list. Okay, your list, strictly speaking, do not all need to be of the same data type. All the variables in the list or all the items in the list now, they don't all need to be in the same of the same data type. So you see in this example here below, we have three different lists. We have fruits, which has strings. Okay, so you see we declare the list using the square brackets, and then each item is separated by a comma from the next item. So this list here has apple, banana, orange, pear, mango, and pineapple. Assign this list to a variable called fruits. So fruits is a data type of list of strings. All right, the next example here we have integers. So this is a list of integers. You see the first one is 80, 97, the last one is 5. All right, so as usual, square brackets, and each item is separated from the next using a comma. Okay, so this is assigned to the variable scores. And then we have a mixed list here. You can see the first item on this list is Andrew, and then we have some floating point numbers, and then finally we have an integer. So in Python you're allowed to have this type of list. So in your labs, as you declare this list, feel free to print them. So you can print fruits, scores, and mixed list to see what you have. Okay, so how do we access members of the list? You can see this is the list of our fruits with 6 different types of fruits. If you want to access a member, we use the square bracket. You can also access other parts of the list still using the square bracket, but I'll talk about this shortly. So you see here we're printing fruits, and then the square bracket, and then an index. We give it an index. Okay, so when you print this, you will see what you get. You get one of these fruits, so I'm sure you can guess that is either this or this, right? So you access the fruits using the square bracket, and then you can supply the index for the elements that you are interested. All right, the item in the list that you're interested in. Okay, then you can also use the colon. So with two index. Okay, so here you see we are trying to access fruits 1:4. All right, so I'm sure you can guess that this gives you some part of the list. Okay, it may not give you the whole list, but it will give you some part of the list. And then there's also this notation here where you access from 2 and then colon, and we don't put any other index after that. That will give us from the index 2 to the end of the list. And actually this is how you should think about it. So you can think of your lists, all right, as items. Each item has an index as shown in this table, and with Python and many other languages, we start counting from index 0. All right, and then you will notice that the last element, its index is n-1 if n is the length of the list. All right, so the length of this list, you can see that we have 6 items. All right, so 6 minus 1 will give you the last item's index. Okay, so the index of pineapple is 5 and the index of apple is 0. So when you print fruits 1, you're actually going to print banana and not apple, because in Python you start counting from 0. Like with many other programming languages, the index, we start counting from 0. Then we have this fruits 1:4. This gives you a range. Okay, so a sub list. So we start from index 1, you see banana, index 2 orange, index 3 pear, and then that's where we stop. You don't actually print or access the index 4. So even though you see the range 1 to 4, the 4th item is not really printed, or should I say the item on the 4th index is not printed. So you stop at you stop one short of this number. Okay, so that's why we print up to pear, but we don't print anything beyond that. All right, then here you see fruits 2 colon, and then there's nothing else, so you print from index 2 to the end of the list. So this is a short form or shorthand method of writing print from so index to the end, so that you get orange, pear, mango, and pineapple in your print statement. So you find this very useful, especially when you do projects that have to do with data science. Okay, where you have to manipulate some data that you have, or even machine learning projects, you may end up using this notation. So it's something that you need to remember. All right, so you practice it and then you memorize it. Then we have this. Now I want you to try and guess what you are likely to get. Okay, so you know that this gives you a list from 2 to the end. How about this? I want you to think about it. Just try to guess what it is that you may get, and then try it and see if what you got was in line with what you were thinking about. Okay, so for our list data structure, you can also update any member of the list using the index, and this is the notation that you will use. Here we have an example. So we're replacing the element on index 3 with watermelon. Okay, so we're assigning watermelon to the third element in or should I say the fourth element now in index 3, because we start counting from 0. Okay, so once you do this assignment, print fruits again, and then you will see that one of your fruits has changed. Let's see if I can go back here so that you see what's on element 3, which is pear. Okay, pear is on element 3. So after you assign this watermelon to the item on index 3 and you print it, you should see that pear should be replaced with watermelon. You can also delete from the list, and we use the remove function to do that. Remove is an inbuilt Python function for lists. Okay, so you call the list name or your list variable dot, let me go back. So you call your list name or variable dot remove, and then the actual element that you would like to remove from the list. So I want you to try this example. What happens when you write fruits.remove apple and then print fruits? What do you get? Okay, so you can try that in the labs and see what you get. Then we have a question here. How do you remove the fruit with index of 3? Okay, so if you know how to remove apple, that should give you a hint of how to remove the fruits with an index of 3. Okay, so you can try that out, so you know that this is how you access fruits of index 3, right? So you need to just plug it in here. All right, and then you'll be fine. Okay, so basically try this and see whether these statements now helps you to remove the fruit that had index of 3. Okay, so there are many list functions. I've just given us some few here on this slide, but as you go online, particularly to this Python documentation using this link here, you see some of the functions of the lists. You can also Google and then find out more list functions that Python has. Okay, so but on this slide you see we've seen append already. We've also seen remove from the previous slide. There's also clear. So clear removes all the items on the list, so it basically does what its name suggests, it clears the lists. Then we have count. Count will help you to count all the elements in the lists, okay, so that you know how many things your list contains. So this will be very useful for you. We also have pop. What pop does is it removes and then return the last element in the list. Okay, so subsequently in the slides you'll see where I use this as an example. All right, so this can be useful. Then we have sort. Sort helps you to maybe arrange the list, whether it's in ascending order or in descending order. Okay, so for more list functions you can Google them, just search online, or you can even check the Python 3 documentation. Then we have another data structure. It's called tuple. Okay, so tuple is a data structure in Python like lists, but unlike lists, your tuples are immutable. Your tuples are immutable. That means that the values don't change. So once you've declared your tuple, however you've declared them, the tuples values don't change. So basically, if you have items that are constants, you can use your tuple to declare them. Okay, because your list, the values can change, but your tuple, the values don't change. Tuples also have index. Okay, they are indexed by integers, just like your lists. All right, so you can access the members of the tuple just like you do with your list using the square brackets. All right, now we have some examples of how to declare some tuples. This first example where you can see the cursor, we're declaring the empty tuple. That means there's nothing inside the tuple, and when you print it, you actually see that it's empty. Then you can also declare a tuple that has two string values. So basically, we've declared a list called num list. So this list has 1, 2, 4, 5, 6, which are 5 different integer values. And then you can now create a tuple out of it by just saying tuple, and then in brackets you pass the name of the list. So you can print this to see the tuple that you get. All right, so from a list you can create a tuple using this tuple function. All right, so we also have here, we're creating a tuple, and then the tuple has different data types. So it has an integer, and then it has a float. Okay, so you can also have mixed tuples, just like how we have mixed lists. All right, so you can feel free to experiment, create tuples, have integers, lists, booleans, and then print them and see what you get. All right, so tuples are similar to lists until the end of the program. So you can't change the values in the tuple. And as you can see here on this slide, you can't update the values of the tuple because so you can't assign 8 to replace what is on index 0 here. So instead of having 1, you want to replace it with 8. You try something like this, you will get an error in Python because tuples are immutable. All right, so though tuples are immutable, you can concatenate two or more tuples together using the plus operator. Okay, so in this example, you see vegetables. Vegetable is a tuple that stores two string values. One is potato, the other one is tomato. All right, and then we have fruits, another tuple that stores mango and orange. So you should see a tuple that has concatenation of these two. So potato, tomato, mango, and orange at the time. If you want to delete the tuple, you can use the delete command in Python. So you just have delete and then the name of your tuple, and this is an example here. So if we've declared this tuple called num_tup, you can delete it using this statement. So just delete del and then the name of your tuple. This will delete this tuple. All right, so that your memory is free, and then other things can be stored in that with that space. All right, you will notice that you cannot delete any element in the tuple, just because of the same reason why you cannot update any element in the tuple, because your tuples are immutable. So once you've defined them, you cannot change their values. Okay, then the other data structure that we'll look at is called dictionary. Okay, dictionary. And dictionaries, basically you can think of them as collections, and they usually have keys and values. Okay, so they are key value paired. You can use them like a map to store values, so they store data like a map, and then each key holds a single value as its element, and this is an example here. So if you have a dictionary called fruits, all right, this is how you can declare it. For dictionary, we use the curly braces, all right, so curly braces, and then you can see that we have a key and then a colon and then the value, a key, a colon, and then the value, a key, a colon, and then a value. Now this key can be of any data type, so it can be an integer, it can be a string, it can be any appropriate data type. The same thing with your values. So your value here can be a string, it can be an integer, it can also be a tuple, it can be a list. All right, so it can be any data type that is appropriate for your use. Okay, so dictionaries can be very, very powerful, and they can be useful for your programs. So you can try different things with them just to get an understanding. All right, but just play around with these codes and see what you can get. So another example of a dictionary here, you can see here the key name is a string. All right, the value also is a string. You see another one, the key here, age, is a string, and then the value is an integer. And then here the key is height, and then the value is a floating point number. All right, so just to reiterate, your dictionary, you use curly braces with them. All right, and then you can now of course they are comma separated, and then you can also have keys and values, and the key doesn't have to be strictly speaking integer. It can be any data type. It can be an integer, it can be a string. It depends really on your use. So when you try this, then you print and see what you get. So here we are printing this string called person. So /n means that you are going to print on a new line. So this is the new line character, /n for new line. All right, so /n, and then person, then colon, and then colon, and then you see there's a small space there. All right, then we print person, which is going to print this dictionary. Now to access the different elements in the dictionary, you can use your square brackets. Okay, and then you want to pass the key as your index. All right, so similarly, just like how you access values in your tuple and in your arrays, you use the square brackets. Sorry, your tuples and your list, you use the square brackets, but this time you pass the key. All right, so you notice that name is a key inside this person dictionary. All right, so this is how you access the value stored inside name, and then you can also print it out to see what you get. Okay, so these are just some few dictionary methods that you may see in Python, and they can be helpful for you. So we have the clear method, right? So your dictionary dot clear to clear all the elements from the dictionary. We have copy for copying. We have get. You want to get a specific value, okay, which is key. You can use this as well. So this is another way of accessing the values of the dictionary. Okay, and then you can also look at the other ones and see what they do. So this is similar to the pop in a list. You can try it out and see. So these are just some few methods for dictionaries. If you need more, you can go online, either Google to search it, or you just check the Python documentation to read more about it. Okay, so after going through all of that, these are certain things that I would like you to be able to answer for yourself. Okay, so you should be able to know what the bitwise operators are in Python. You should be able to talk about the operator precedence. That means if you have an operation that has several operators, which ones have the highest priority. So for example, if you have an arithmetic expression with plus, minus, divide, which one does the compiler or interpreter would does do first? Okay, so will your Python interpreter do the division before plus and minus? So that's what we call operator precedence. You need to know that. You can practice to see what you get. Then you should be able to know some basic operations, okay, in Python, and then also how to access, a list, items in a list. If you have -3 as the index, what do you get? So I know in the examples that I talked about, you didn't see any minus value as the index, but I want you to try it yourself and see how Python behaves. So what happens when you have minus something as your index? Then you should know the similarities between your tuple and your list, and also the differences between your tuple and list. So try to go through these 7 questions and see if you truly understand some of the things that we've spoken about in the previous slides. All right, so moving on, we've now covered variables, operators, conditions, and conditional statements. Now we've also covered data structures. So the next thing we need to, when we have state, okay, and these are some of the loops that we may look at for our lectures. So we'll look at the while loop, the for loop, and then what is called the nested loop. Okay. So for the question I'm seeing in the chat, the scenario when we'll know to use a tuple instead of a list. So you can use a tuple instead of a list when you're talking about constants. So if the values are not going to change, then you will use a tuple. But if the values are going to change, then you can use a list. So it really depends on what it is that you're trying to do. Yeah, so Courage, I'll need you to be more specific with your question so that I know exactly what you want to access with the dot notation. Okay, so just be more specific with your question so that I know what you want to access with the dot notation. Are you talking about a list or a tuple, or what is it? All right. All right, so back to the slides. The while loop. So this is the structure of the while loop. Basically, you have a while expression. Once this is true, then your statement or statements will be under this indentation. All right. So basically what happens here is we repeat all these statements as long as this while condition is true. Okay, we repeat all these statements while condition is true. this expression here, while it is true, we'll repeat all of this. But once for any reason this becomes false, then we exit the loop. Okay, we exit the loop. All right, so we have an example here. We have count equals 0 while count less than 10. Okay, and then count equals count plus 1. Okay, to update the count, and then want to print a new line, and then we'll add also the count. All right, so you can try this and see what you get. Okay, so you can try this code and see what you get, but basically what you should get is a count from 1 to 9. All right, or yeah, 1 to 9. Okay, let's see what we have next. Here we have a list. So the list has some fruits, all right, and is assigned to fruits. And then here you can see we have while fruits. So sometimes you may not have a condition, like let me check the previous slide. You see here we have a condition. You see count, and then we are using the less than operator, and then there's a number here. Here you see that we have a variable, and in Python this is just a short way of writing basically all your variables that have values. Okay, when you use them as conditions, they will evaluate to true. Okay, they will evaluate to true. So this is going to be true unless it does not have a value inside it, then it will now be false. Okay, another thing to note is if you have 1 while something is 1, that or 2 or 3 or whatever, as long as it is not 0, that will also evaluate to true. Okay, but once you do while 0, that is going to evaluate to false. In that case, you don't really go into the loop. So while fruits is what is going to do is, as long as there are fruits inside this list, we'll keep entering this part of the code. All right, and this part of the code says that you should print the fruits.pop. So remember, you have seen pop before as one of those list methods. Okay, and what it does is that it removes the last element from the list and then displays it or returns it. Okay, so if you run this code, you will see something interesting. So I would like you to try it for yourself and let me know what you get. Now you see we have another while condition here. So this is similar to the condition that you have seen before, but the way we've written this statement is different. Now you will notice that we still have colon, but we didn't indent. So in Python you can do this. So it's going to treat this as a statement, then treat this other part too as a statement. So try this and see. So this can be an alternative for you if you don't want to write it the other way. Okay, but this also should count, okay, from 1 to 9. You will notice here that this counts, the way we are updating it, we are using the plus equal 1, which I'm sure you guys would have remembered from the slides we saw last week. All right, the addition and then assignment operator, if you remember from last week's class. So this is one way of using it. Okay, all right, so we have, in this case, we are looping through a string. All right, so we've looped through a list. Now we are now looping through a string, and you can loop through a string. You can think of a string as a list of characters. Okay, you can think of a string as a list of characters, and then you can write a loop to loop through it. All right, so in this case we have index. We start index at 0. So remember, just like how your list had from 0 to n minus 1, where n is the length of the list, the same thing for your string. So its strings also have, for each character, they have an index from 0 all the way to n minus 1, where n is the length of your string. So while your index is less than the length of the string, this len function gives you the length of something, in this case length of string. This will give you how long the string is, how many characters in the string. All right, so while this condition is met, then we can now do this loop. You will notice here that I'm checking the string, the particular index and the string. I'm accessing the string, the character, using this. Okay, I'm checking if it's a P or if it's an E. All right, then I now add the index. Then there's a keyword here highlighted in green, or should I say colored in green, continue. And then here we have print, and then also we are incrementing our index. Okay, so I would like you to try this code and see what happens. You will notice that, just like the comments tells you, this will print all the characters in this string except the P and E characters. They will not be printed out. All right, and this P here, sorry, is supposed to be lowercase p. Okay, lowercase p, as you see in the condition. So I need to correct that. So that's lowercase p, not capital P. You notice that capital P is printed out because, like I told you in earlier lecture, that in Python, the Python language itself is case sensitive, and because it is case sensitive, it doesn't treat small letter p as capital letter P. All right, so you need to be careful with the code that you write, because Python is case sensitive. Okay, and because it's case sensitive, you should anticipate the type of behavior that your code gets vis-a-vis what you actually expect, and make sure that everything works in order. All right, so try this in the labs, then play around with it, maybe change the characters that you're looking for, and then see what you get. You will notice that you have another something here, or. So our or operator. So you've seen operators in the previous lecture, right? So you notice we have or here, and we have this double equal operator to check if two things are the same. Okay, so basically we are checking if the character that we are on is either P or if the character is E, either of these. All right, so the continue keyword, what it does is that once it gets here, instead of coming down here to this remaining part of the code, we go back here to this condition. All right, that's what continue does. So where you see continue inside your loop, it doesn't execute anything below it. Rather, from this continue, it comes back to check this condition for the next iterative item, and that's because here we've increased the index. If we had not increased the index, then we would have been in trouble. So you need to be careful how you use some of these things in Python. Okay, so you don't want to have an infinite loop, so make sure that this condition at some point is going to become false, and then make sure that this doesn't bypass whatever is going to make your condition to become false. Okay, so when you try this code, you should get this type of results, okay, where your current character is capital P, then small r, then M, then I, then N, then T. All right, but the small letter E and the small letter P in peppermint should not display. Okay. All right, then here is the same program, but this time you see that we have a different keyword. So we're not using continue now, we are using break. And what break does is that you come out of the loop here. All right, so once you've done all of this, when you come here, you don't do this again, you come out of the loop and you don't come back here. You just come out and then continue the other lines of the program below this. All right, so that's what break does. So you come out and continue the program. So once you run this program, you'll see that you only print capital P and you don't print any other character, okay, because you've oh, sorry, the break, what it does is you come out and continue. So you come out of the loop and then you continue. All right, so that's what the break does. So you can try it and see. So you come out and then continue the program. Okay, so I would like you to, when you try this program, you just note that because capital P is not the same as small letter p, this condition is not met. So initially you won't do anything inside this statement. You come out of this, you won't enter this loop, rather you come here and you print this, okay, then you increment and then you come back and do for the next one, which is E, and E matches this part of the condition. So you increment, then you break, and then when you break, you come out of the loop and then you do any other thing outside the loop. So all these statements inside the loop will no longer be executed. That's what the break does. So you come out of the loop and then anything under the loop is what you will do. Then there's another keyword called pass. All right, so I want you to try replacing this break with pass and see what happens. Okay, so as you do your labs, try and see the behavior when you replace break with pass. Okay, you can also loop, besides looping through a string and looping through a list, you can loop through the other data structures that we have: dictionary, tuples, and sets. So I want you to look up sets on your own and see what it is. And the way you will loop through all of this with the for loop is that you declare a new variable here, and then you use the keyword in, and then the name of your list or your string or whatever. All right, then after your colon, you put your statements, and your statements have to be indented. So this is the structure of the for loop. So we've seen how the while loop works. Now this is the for loop. All right, so with the for loop, you don't necessarily need to keep increasing your index, maybe giving an index and increasing it. No, you can write it this way: for variable in, the variable that you are looping through, which we call an iterable, okay, do something, and then your iterable can be a string, tuple, lists, and so on. All right, so this is an example here. We have a list of fruits. All right, and inside this list of fruits, you can loop for fruit in fruits, and then you print fruits. All right, so try this yourself and see what you get. So this is an example. We are looping through the list. You notice that the variable here that we are using is called fruit. It's not the same as fruits. Okay, so just make sure that when you write this code, you don't mix it up. Okay, this is the list that you are trying to loop through. This is one item inside this list. Okay, That's what this fruit here is. One item inside this list, or one fruit inside this list. Okay, so try this yourself and see. You can also loop through a dictionary this way. So you see here that we have a dictionary. In this case, we declared an empty dictionary this way using the dict function. All right, and then just like how you update a list, here we are updating this person dictionary. So we have a new key called name, and then we are assigning this name Alimeiko to this key. All right, and then the height is also a new key. We're assigning this into this new key, and then we can now write our loop. So I want you to try this loop and see. For each individual item, which is called I inside person, we are now printing the statements. Okay, so we are printing I, which is the item, and then we are printing person, and then the square brackets, and then I. So this square bracket is to access what is inside the key. So remember, the key is the I. All right, so you will notice that now we are using this. This is not a type of print statement that you may have seen before. All right, where we have the F before the quotation marks. All right, and basically we do this for what we call string interpolation. Basically, these things inside these curly brackets here, they are variables. Okay, they are variables that have values. Okay, they are variables that have values, and basically what happens here is that the value is what is going to be printed out, and not the I itself or the variable name. Basically, that's what that does. You can try it to see. Okay, so I think for those of you that have asked some questions in the comments, you just give me some time. Maybe when I'm done with the lecture material, I would make time to address your comments. Okay, so just be patient with me. All right, so now we have an instance where we are looping through a string. So you can see the string here is stored inside sentence. The string is Python is a cool programming language. All right, so for S in sentence, we're going to print S. You can try that out and see what you get. You can even guess before you try it out. All right, and then check whether what you got is actually what you guessed. Now we have this concept of the nested loop. So when we say something is nested, that means it's inside another thing. So similarly with what we saw with the if condition last week, how you can have nested if. With your loops as well, you can have nesting. So you can have a nested for inside another for. Okay, and this is an example here. All right, so this is a type. This is something that you may end up doing a lot of in Python, where you have to store data in using two or more data structures. But whatever you do, make sure that you don't make this complex, because when you make it too complex, you may have issues when you have to start doing your loops or your nested loops. So in this case, you see that we have the variable called people, and people is a list. We know it's a list because of these square brackets. These square brackets make us know that people is of the type list. And what does this list contain? Well, it contains dictionaries, right? Because of the curly braces. Because of these curly braces, we know that these are dictionaries. Okay, in this case, there are two dictionaries. So we know that people is a list of dictionaries. Let me take that again. People is a list of dictionaries. All right, so that's the data type of people. It's a list of dictionaries. Okay, so we have two dictionaries, right? And each dictionary has a name as the key, and then name as value. Then they have age as another key, and then a integers as value for that. All right, so if you are looping, you can write a nested loop like this for person in people. All right, and when you do that loop, basically what you'll be getting is this list, this dictionary, and then this dictionary. So person at this point is one of these dictionaries. Okay, so person at this point is one of these dictionaries. Then you can now say for another variable in person, then you want to get something. So here we're using property. So this time now we're looping through each of the dictionaries. Okay, we're looping through each of the dictionary. So one property can be what? Name. Another property can be what? Age. Okay, so we'll print the property and then the value of that key property. All right, so I want you to try this code and see what you get. Okay, all right, so we're coming to the end of the material now. We can also have nested while loop. Okay, so a while statement inside another while statement. All right, while expression, good. And you see an example here. So we have an index I, another index j, and then a loop that goes from I less than 100. Okay, and we keep incrementing I, as you see here, we keep incrementing I. And then we have one for j less than equal I divided by j. Okay, and then we are doing something here. So I'm sure you guys remember the not operator and also the modulus operator for remainder, right? And then you are seeing the break keyword again. So I would like you to try this code and guess what it's trying to do. Okay, even though this statement gives it away, right? But try it and try to guess what it does. You can try that in your labs. All right, so at this point we've covered variables, we've covered operators, and then we've covered conditions and conditional statements, and we've also covered data structures and loops. So the next thing we'll need to touch is functions, but I think so that I don't overwhelm you with too much information, we will not go into functions now, but we'll go into functions in the next lecture that we'll have next week. So I want you to try all the examples you've seen in the slides during your lab sessions tomorrow. I'll forward the notes to your class rep, and then just try everything that you've seen thus far. So all the examples you see in the notes today, plus the examples that you had last week, I would like you to try them out and see what you get. At this point, let me just take a few moments to answer some of the questions we have inside our chats. Okay, so let's see if I understand courage. In a dictionary where you use the brackets to access a value, okay, the square brackets, can you use the dot notation? So if I go back some few slides to those functions of the dictionary, so you can use this third one, dict.get. So the name of your dictionary, so if your dictionary is person.get, and inside this get method you put the name of your string. All right, you put the name of your string. So if maybe what you're trying to get is the name of the person, you can say person dot get, then in quotation marks you put name. All right, you put name. So let me see if I can type it in the chat. Okay, all right, so Courage, you can use person dot get name. All right, so this is an example. Okay, so this is an example, that and this is for the person dictionary. All right, for person dictionary. Okay, and then also for person dictionary, if you decide, you can also access it by saying person and then name. All right, so either way is fine. All right, either way is fine actually. So either way is fine. Let's see. Samuel Yusuf, we are asking if Python utilizes return. Yes, Python uses the return keyword for your functions. So when we see functions in the next class, you will see an example of the that. Okay, so Courage, no, you don't use that. Okay, yes, you don't use person.name except you now define a class called person. Yes, so you don't use person.name except you define a class called person. All right, except you define a class called person. We will look at classes in the future. So for your dictionary, you will not use person.name, no. But when you define the class, and then the class is a person and it has an attribute called name, then you can now use person.name. So you will see that when we now start talking about the object-oriented programming in Python. All right, then the last question is for Yusuf. Okay, in the nested loop, is people and yes, you can think of people as objects. Okay, if you are dealing with a language like JavaScript, that's what we'll call that objects. But for Python, we call it dictionaries. Okay, so in Python we call this dictionary. So the persons, each person here inside this people list is a dictionary, and that's how you should think about it in Python. Okay, so I think in the absence of any questions, we'll stop the session here, and hopefully from the next class we'll continue from functions. All right, so I want you to practice all that you've learned thus far in the labs. So start from variables, the conditions, the operators, and then now that you know data structures and loops, mix and match everything and see what you get. All right, so besides trying all the examples in the notes, try some other things that you may think about. All right, and if you have any questions, when we meet, we will talk about them. Okay, so I thank you all for coming. I'll see you all next week. All right, thank you.